In this video module, we are going to be looking at section 9.4 covering dilation. If at any point I go too fast in the video, please feel free to just hit pause and get caught back up. So the first thing we're going to do is define dilation. Well, dilation is simply a transformation that stretches or shrinks a figure to create a similar figure. Now the key word there is similar. Now, similar is going to come back in chapter 6 when we do similar triangles. So since it is similar, it is not the same size, but it is the same shape. Therefore, this is a non-rigid motion problem. So if you look over here in this picture, you can see ABC and XYZ. A dilation has been performed on this. So the pre-image, I need you to know, is ABC. The image is going to be XYZ. Now they are both triangles, so we are going to notate that they're both triangles with the triangle symbol. Now, something called the center of dilation. So the center of dilation, and in this picture, is going to be in respect to the origin. It is just the point of dilation. Now, I'm going to explain that a little bit more in respect to the origin. So it is here. And there's two notations for this. Capital D is for dilation with respect at the origin or wherever it's going from, or simply a capital D and a capital O for origin. So what has happened here is that A, B, and C, so A, B, and C all originate from the origin. So as they get dilated, it goes in the same direction and it gets bigger. So that is the point of dilation. Now, I do want you to know that these can be enlarged as shown in this picture, or they can actually be reduced, which we'll do an example of where it is reduced. Now, one of the most important things about a dilation is something called the scale factor. Now, the scale factor is a ratio of side length of the image to the corresponding side length of the original figure. Now, this is very important that you understand that order matters here. So if you notice in the definition, it says the image to the original figure. So up here at this picture, you can see we have the pre-image in blue, and then we have the image in red. So according to this, if I take this XY right here, the actual length of that, and I take the corresponding here, which is AB, that is going to give me my scale factor. And the scale factor is going to tell me if it is enlarged or reduced. Now, let's go down here and let's do this investigation together. I have given you a triangle ABC with vertices of A, B, and C. I have already graphed this for us. Now, number 1 says, using the origin as the center of dilation, draw the distance to point A. So what it wants us to do here is it wants us to take the origin and draw up to A. So we're going to go from there to there. Now, it says using a scale factor, plot E. Now, what this is wanting us to do is it's wanting us to count up, and over. So that is up 3 over 1. It wants us to go up 3 over 1 again. And right there, it wants us to plot what we are going to call plot E. Now, basically what we have done, we have created an array that's extending to create that second distance of E. Now, it says to repeat this process for points B. So I'm going to draw that line there. I'm going to see what that slope is. That goes up 3. And it's going to go over, let's see, 1, 2, 3, 4, 5. So I need to do that again. Up 3 and 1, 2, 3, 4, 5. So there is going to be our next point, okay? So since they started us with E, we will go F. Now, if I extend this line on out, it's going to go through F. And you can see we are dilating from the origin. Now, we need to repeat this process to C. So from C, we're going to draw this line here. And then we're going to count that slope. We go up 1 and 1, 2, 3, 4, 5. Up 1, 1, 2, 3, 4, 5. And we'll call this E, F, G. Now, if I extend this line again, this is being dilated from the origin. So from here, it says draw XYZ, which this is actually supposed to be draw E, F, G. So we're going to draw this new E to F, F to G, and E to G. So we're going to draw that in there. Now, that is our new figure. It is the same shape, but it is 2 times bigger. So this is the conclusions that I want you to make. This distance here, so this distance here, and this distance here, that is half of that, or that is double of that. From B and then out to BF, again, 1/2 or double. And the same thing from C all the way out to G, it is 1/2 or double. Now, since it's wanting us to make conclusions, we are going to do something very quick here. Section A to B is 1, 2, 3, 4 units. So I'm going to put a 4 right there. And E to F is 1, 2, 3, 4, 5, 6, 7, 8. Now you can see 4 to 8. Now if I do the scale factor, because order matters, EF corresponds to AB. So the distance of EF was 8, the distance of AB is 4. Therefore, I have a 2. That means I have a scale factor of 2. Now, let's check that somewhere else. So let's go over here and check FG. So FG is 1, 2, 3, 4 units. And BC right here is 2 units. So if I correspond FG to BC, I get 4 units to 2 units, which reduces down to a 2. So the conclusions that we can make from this investigation is that we have a scale factor of 2, and we also can conclude that triangle EFG is a dilation. It got enlarged. So it's a dilation of triangle ABC. Now, one thing that I really want you to pay attention to is how everything started at this origin. So I dilated that out. Now, since that is the case with the origin, we do have coordinate notation for dilations. It says you can describe a dilation with respect to the origin with this notation. We have an ordered pair, x, y. We can change it if we know the scale factor by multiplying x and y by the scale factor, which we call k. Now, k is the scale factor, and there are rules that we know that can apply to the scale factor. If k is between 0 and 1, it is a reduction. So this would be 1/2, 1/3, 0.4, anything between 0 and 1, but not including 0 and 1. If k is anything above 1, then that is an enlargement. Now, let's do one where we absolutely know. It says, number 1, draw the dilation of ABC using scale factor of 2. Now, again, notation. So the notation of this one, since when it's not stated, we automatically assume that we are doing it with respect of the origin. So we say dilation at the origin, comma, that k comes in there. Sorry about that. So we put the k there. Okay, sorry about that. So now we have the dilation in the notation. So now this is what our job is. Our job is to take the x's and the y's and to transform them with the dilation of 2x and 2y. So the first thing I'm going to do is I'm going to list my points A, B, C. So A is right here. That is 1, 1. B is right here. That is 2, -1. C is right here. It is -2, 0. Now we are going to transform them by using the dilation scale factor. So this is now going to become 2, 2. This will become 4, -2. This will become -4, 0 when I multiply everything, x and y, by 2. Now I'm going to graph these. 2, 2, so we can call this A prime. 4, -2, that can be B prime. And then -4, 0, that can be C prime. So I'm going to connect my vertices. And as you can clearly see, I now have a bigger diagram because the scale factor was above 1. Therefore, I have a dilation enlargement of triangle ABC. Now, question 2 is the same thing. It just is a reduction because we have a scale factor of 1/4, excuse me. So I would like for you to pause this video and try that problem.